Welcome everyone. Welcome to today's webinar about CUTLER. It's the 7th webinar in a series, and today's topic would be Big Data Analytics for Sensing the Social Consequences of Urban Policymaking. And we will present the CUTLER methodology for estimating the social impact. We are Jun Sun and Dr. Chandan Kumar from the University of Stuttgart. And this is one of the many CUTLER webinars, and it is live streamed on Facebook, and it will be recorded. The video will be openly shared on YouTube and Facebook. And the presentation slides will also be shared on the CUTLER website. Please kindly mute your microphone during the presentation. And if you would like, you can of course switch your camera off. That would save some bandwidth because we are recording it. And I will be glad to answer your questions after my presentation. You could, at the meanwhile, write your questions in the chat. And you could also raise your virtual hand and ask the question yourself. So we are two persons from the University of Stuttgart in Germany, and we both joined the CUTLER project 3 years ago. At that time, we were both in the University of Koblenz, which was also in Germany, and later we moved to the University of Stuttgart together. I am Jun Sun, and I'm a scientific researcher at the Analytic Computing Group in the University of Stuttgart. I did my master in the TU Dresden, and my main interest in research is machine learning techniques applied to the web and network science. I have many years of experience in EU projects of social data analytics. And my colleague, Chandan Kumar, say hi.
Hi, I'm Chandan. So I am basically working in human-computer interaction and also in data visualization and data analysis techniques. I did my PhD in 2016, was working in Koblenz as a postdoc researcher, and recently moved to Stuttgart. So because the project is continuing in Stuttgart now. Yeah, so feel free to ask any questions to Jun or to me during the whole presentation.
Thank you. And we go to the actual point of the slides. So this is the outline of today's talk. First, we show an overview of the CUTLER project and what role we play in the project as the University of Stuttgart and the work package. And then we show the detailed data processing workflow from data retrieval to data filtering to data analytics, and then visualization and interaction with the data. In the end, we show our scientific contributions. So this is like the overview of the CUTLER project. If you have attended one of the seminars, probably you have seen it. And so we, as a whole project, get the data from different sources like open data, statistical information, sensor. There are a lot of sensors, and there are also user-contributed content. And then we analyze the data in 3 fashions. First is the economic activity, and the second is the social consequences, and the third is the environmental impact. And our colleagues have already explained the economical aspect and the environmental aspect. And today's focus will be on social consequences. And then we follow the Yammer process in decision making, and then we use this result in our 5 pilot cases that will be shown in 1 minute. And this is like a cycle, so this does not stop here, but it runs like a cycle during the project, and of course will continue after the project. We have 5 pilot cases. first pilot case is Thessaloniki, which will manage a controlled parking system near the waterfront, and they are also implementing a water transportation system. The second case, Antalya, is managing the Dylan area, which is a waterfall, a very nice waterfall, but there are some challenges, which is the amount of water in the waterfall, and they want to better balance every aspect, social, economical, and environmental, when managing the waterfall. Third use case, Antwerp, which is implementing a strategic urban water plan and garden street design and assessment, because there are a lot of waterfalls in this area, and garden streets will be helpful to contain this water when there's flood, for example, and it will also be beneficial to the citizens in different aspects. And let's go to the fourth use case, which is the Cork County, and it is trying to enable visitor access to the Camden Fort Marga, and it can be done in different manners. For example, bus, public transportation, cars, and even water transportation system. In the later of the project, there's another pilot case, which is in Cinza in Italy, and the city is often flooded by the river you see in the picture, and in order to protect the city against the flood, it is necessary to analyze different kind of data to protect the city. So we see all these 5 nice pilot cities. They all have water elements, as we have seen, and what we do is not only tackle every problem they see, but also try to provide a general solution to deal with the social impact, as we see. Because later, when they have some more issues, they can easily adapt our system to deal with the challenge. And even for other cities, for example, if they have similar problems, you can also use our general solutions for social impact analyzing. Of course, I will see how we deal with each and individual challenges and how we fine-tune our solution to each of the pilot cases. So our methodology for sensing the social consequences of urban policymaking in CUTLER is defined as follows. First, we retrieve a lot of data from either online or offline sources. And you see all these kind of data. They are arguably the most famous data sources, like Twitter, Facebook, or TripAdvisor in some cases, but also some offline sources like questionnaires, survey data, and also statistical data of the city and the country. And then we analyze the citizens' opinions and also geospatial, social characteristics for this evidence-driven policymaking, which is what we aim in the CUTLER project. We use text mining, opinion extraction, geospatial analysis, topic modeling, and thematic summarization techniques to analyze and compare the social data and also demographic data, like the statistical data we have seen. And finally, we visualize our data and the analytical results with Kibana, which provides nice little widgets and dashboards for the user to be more interactive with the data. This is like our structure of our work package. So imagine you are a user, you sit in the front end and you interact with the system with some queries. For example, you are interested in some aspects like Facebook, Twitter, or TripAdvisor, and then you enter your query, and this query is received by our system via the Apache Kafka message protocol, and then the backend will receive your request, and then it will do everything needed to fulfill your request. For example, first filter the data and then extract data. Sometimes we have pre-processed the data already in the system. Sometimes it's alive, so it's real time sometimes. And then we do the analytics, and then in the end we show the result and the summary with Elasticsearch and the Kibana stack, which will show some example hopefully today live if the WebEx system allows. And also in the system we include different kind of filtering and analytics, for example, geospatial, keyword, semantic, or temporal, or even semantic analysis, like sentimental analysis, sorry. So as I explained, this is the workflow, how we deal with the data. We retrieve all kinds of documents. This can be everything, as we have shown, like TripAdvisor, different things. And we pre-process data so that they can be dealt with in the same manner. And then we do topic modeling or clustering algorithms. And this is to reduce the amount of data that is shown to the user at the first glance. For example, you receive a lot of data and you might get lost very easily. But if we group the data according to their topic and present the cluster labels or the summarization of each topic, and then we show the ranking. For example, we show that some documents are most relevant to your request, and we show them at first, and we show the less relevant documents at the last. And this is a good way to visualize the documents, if there are many documents, of course. Yeah, and when we perform the sentiment analysis and summarize the results to our user using Kibana. Next, we explain the data retrieval and filtering process. First, let's look at different data sources. So Twitter is arguably the most famous social network in the world, and we want to see what's happening and what people are talking about in these pilot cities in order to analyze the social aspect of policies and citizens' opinions online. And for this, we have retrieved tweets and retweets for the 4 pilot cases. They are Antwerp, Antalya, Cork, and Vicenza. And since Vicenza joined late, there are not as many tweets as the other 3 cases. We also have tried this approach to Thessaloniki, but it turns out not very helpful. So really, in different cases, you have to consider different things. There's no one key for every door, but you really have to consider the speciality of different cases. Yes, so here you see a nice little picture on in Twitter, and showing the nice view of the Camden Fort Mache, which is in the Cork County. And we retrieve the data with Twitter API based on the geolocation of the cities and also the keywords related to the pilot cases. For example, in this case, it would be Camden Fort or Camden Fort Mache. Next, we present the GDELT event data as another data source for gathering data about current events. The GDELT project is founded by Google, I think, and it continuously monitors all kinds of news and events from all over the world in more than 100 languages. And you can also retrieve the raw data from the website. It is open access, and the data is indexed every 15 minutes based on the geolocation. So we retrieve the data based on the geolocation of the pilots. As I explained, I do not want to limit the system to only the 5 pilot cases, but I wanted to present a general approach. That's why I showed this graph, which is an example of plot of all events in a 15 minutes time frame contained in one data file. And each dot here expresses one event, and the darker the dot is, the more it is referred to. So you can understand it as the importance of the event. So you can really see all kinds of events happening all over the world. News and comments data is another data source. For the CUTLER use cases, for example, if you want to analyze news articles, their user comments, because they can provide insights including the emotional and the opinion of users, and which can of course be used to get the constructive criticism or different aspects of the policy making. For example, the urban planners of the Thessaloniki municipality are interested in implementing a sea transportation system and a controlled parking system, which have already been implemented in other cities all over the world. They are not very new. They are just new to the Thessaloniki municipality. And of course, then you can check the reaction of other people who the people who are in other cities who which have already implemented these policies. Retrieve the URLs of news and comments using the news API based on keywords and time frame. And then we extract the user comments. And there are a lot of challenges, because for different news websites uses different implementation of the comment section. Some uses standardized comment section implementations like Discuss or Open Web. Some use their own implementation. Some really do not want to implement anything but link their news to Facebook, for example. That's why it is a bit challenging to extract everything, but we try to extract as many as we can. TripAdvisor data. In the second half of the project, we have identified that the TripAdvisor data is extremely useful for policymaking, especially for some pilot cases, like, for example, Cork or Antalya. They have use cases which are closely related to tourism. For example, in Cork, they have this Cannon Fort Maher, and it is already well received in TripAdvisor, as we can see in the comments. Of course, they are anonymized, and you see lots of visitors' reviews, and there you can get different things. For example, if people are complaining about certain things like accessing to the fort or transportation or different other things. The same for Antalya Driven Waterfall, and you can see a lot of comments in the next slide. The TripAdvisor data is also useful for tourist sites, like in Vicenza, because they are potentially influenced by floods. So we would like to see if they are really complained by the visitors, whether the flood is really a challenge. Or you can see that the tourist sites in or outside Thessaloniki that are relevant to the pilot use cases, which is the water transportation system, as we can see in London, in Venice, for example, they already have such kind of water transportation system, and the city planners in Thessaloniki wanted to see the reaction of the visitors. So here are more examples, for example, in the lower Duden waterfall, which is closely related to the use case in Antalya, which is the upper Duden waterfall. And people have different opinions on TripAdvisor. Of course, again, they are anonymized. Some are complaining that although it is a nice place, but the waterfall is almost dry, so there are not enough water. And some people are complaining about certain seasons and the access, for example, not friendly for wheelchair users. So these are really valuable information that can be considered, of course, for the city planners to consider with other information, like, for example, tourism data. So they can consider this in combination with the TripAdvisor data. For Cork, for the entire island of Ireland, we have the raw data as PDF reports for more than 1 decade, and it shows the tourist performance as measured by the total foreign exchange earnings, and also the employments to the influence of tourism to the employments, the local employments, and also how much money the visitors spend and what kind of activities they spend or they played, or how they stay, whether they stay at friend's home or a hotel or what other kind of places. So you see, this is like not only social data, but also kind of economical data, which was already discussed in the last 2 webinars. So, and for the use case of Turkey, of Antalya, we have also the tourism data for the entire Turkey per area. Of course, it includes the Antalya city, which contains the Diden waterfall. Survey data, both in the pilot case of Antalya and Cork, the visitors' opinions are very valuable because the planners can take them into account to better develop the areas. So during the project, they have conducted both online and face-to-face surveys and collect the opinions of the visitors. And of course, they have allowed us to use the data for our analysis. So this, you can see an example of a survey that is online, and it is conducted by Camden Fort Mare. And here you see basic information, but of course there are more things like the experience of your visit to the fort. Same for Antalya. Citizens' discussions on local forums, for example, Improve My City for Thessaloniki, and also their discussions on Facebook, for example, are also very valuable because they often report some issues, like local issues that are really pinpointed to this area. For example, in Improve My City, people often include some photos to explain whether there's an issue, there's a local issue, and also they attach the geolocation and address of the issue with a short description. And in some cases, Facebook posts and comments for Thessaloniki and also for Antwerp, people tend to discuss in Facebook public groups about certain local issues. So these are also one of the important data sources that we consider. And other data sources, of course, social demographic data and census data, and also the controlled parking scan data of Thessaloniki and land use data. Here you see different land use data in different layers. If you combine these data sources, it can really help the the policymakers to optimize the distributions of parking space among visitors and the other people, for example. Okay, so we have defined most of our data sources. And of course, we cannot directly use these data. We have to perform data pre-processing. And this is especially the case for social data because we have different data sources and they are sometimes structured, sometimes not structured. For example, in the tourism data, we see that they are really PDF files that must be extracted semi-automatically. And then, as an example, we show that the user commands from the web are really from different sources. That's why we try different approaches like rule-based classification or supervised classification using machine learning, depending on the actual case. For Twitter, of course, we apply the filtering, which filters irrelevant or duplicated tweets, and we also extract the URLs of the images so that the users can see a thumbnail of the images. And then if they are interested in it, they can click on the thumbnail and then a pop-up will show and it will direct the user to the original tweet. Some data have to be anonymized to protect the citizens, and some data have to be harmonized so that they can be further analyzed in the same manner. For example, geolocation, some people use the city name, some people use the street name, some people use the coordinates. And for different, for date and time, different websites have different visualization and implementation. For example, I post something 5 minutes ago, it shows 5 minutes ago on Twitter, but it really have to be converted to the actual time. After data retrieval and data filtering, I would like to present the actual data analytics, like the general data analytics methodologies that we apply in the CUTLER project. First is topic modeling, as I explained. If you give the users a bunch of data, they might get lost very quickly. But if you group the data, the documents in some fashion, for example, you group them according to the topic, and you summarize the topics in a good manner, it is better for the users to understand really what's going on. And for topic modeling, we have tried different approaches in out there, and the basic thing is the latent Dirichlet allocation, which is considered as the baseline of topic modeling. We have also tried graph clustering algorithms, for example, Markovian cluster algorithm that was proposed and outperforms the baseline LDA. And we implemented different things, and eventually we evaluate on an external dataset. We found out that the hierarchical multi-Dirichlet processes that is proposed by our former colleague Christoph Kling outperforms most of the topic models in the market, and moreover, it uses different metadata for calculating the topic model. For example, timestamp and thread ID, different metadata that is not really the content, not really the text, but metadata. And it also supports topic labeling using trigram model, so you can really give each topic a label that is convenient for the users to see what's really going on. Thematic summarization using deep learning model like Spacey for pre-processing, and we use also unsupervised text summarization with text rank, which is really similar to PageRank, but it is for text, and the PageRank was originally proposed for networks. So sometimes you see a label of the topic, which is not really enough. You really want to see what's the distribution of words and phrases, like the importance of them. And here you see a topic about the visit in Cork Harbor, and so these documents on the left side are in one topic, and on the right side you see the summarization in a nice manner as the result of our analytics. So you see different things like stunning views and local volunteers. So these are what people comment about. And these are not really some trivial phrases like, for example, the views or something, but really the important stuff here. And you can, I will show in 1 minute that you can click on each thing here. By the way, the size of the text shows the importance of the summarization. So for example, if you click on stunning views, it will automatically filter that the documents which contains these phrases. Ranking opinions. So the objective of ranking is to find significant comments which represent the topic of the cluster. And we want to find the most relevant comments in each cluster. And we use MMR, which is the maximal marginal relevance, and it can rank the comments based on their relevance to the topic of the cluster without being redundant, for example. So you see a rank which is given by the algorithm and MMR, and you can sort according to the MMR to get the most relevant comments based on similarity. Sentiment analysis is important to understand the opinion of the users or citizens, and we use the sentiment analysis as well in CUTLER for the comments, for the tweets, for the feedbacks, using our model in NLTK and Spacey, for example. The challenge, of course, is language-specific adaptations because, for example, you see that in our project we have different languages like Greek, Turkish, or Dutch, or even Italian, and in the NLP, natural language processing community, the English is the most well studied, but not for the others. So we have to deal with different challenges. Yes, here you see an example of the results in Turkish language. Social interaction mining. We use community detection and influential user discovery to identify the most influential users in each community. And we also generate word clouds for each community to see what's really discussed in each community. Here, community means a group of users, And the left side shows the result of the clustering of the community detection algorithm. You see different people are grouped in different colors, which indicates the community of them. And the right side is the summarization as word cloud for one or two of the clusters. Of course, we have to combine social demographic data, for example, to the tourism data that we gathered in TripAdvisor. Here you see a case of Antalya, and in the statistical data that retrieved from the Antalya Center, you see a distribution of nationalities of the visitors. So you see the Russian is the majority, and of course there are some Germans. And you see also the language distribution of the TripAdvisor reviews. You see that English is, of course, the majority, and Turkish and Russian and German. So previously it was believed that the Arabian, there are a lot of Arabian visitors, and this contradicts the belief that the city planners have held. So as an example, it really shows the evidence-driven policymaking is really important because it really contradicts with the intuition of the policymakers initially. Of course, you can cross-compare the tourism performance with the user, with the timeline of the, here you see the number of visitors in each of the cases, and you see a pattern here. Next, we want to show the visualization and interaction of the data, because interaction is the most close thing that the users touch. So the users won't touch the data retrieval, won't touch the data analytics directly, but they touch the interactions, visualizations directly. So we have already explained how to establish the visualization widgets and dashboards in one of the previous webinars. So today's focus is not to how to establish or how to build these queries and widgets, but really showcase different things that we build for social data. The idea is to say for each data sources that we expand, there's a dedicated dashboard, and later it can be integrated in the later work packages. For example, next week you will see our colleagues explaining how to integrate the system together. You see different widgets here popping up. So this is like our Twitter dashboard. It contains a tag cloud, as we can see here, which shows the distribution of tags. And you can also see the geospatial mapping. In the map, you see a heat map, which indicates the spatial distribution of the tweets. You can locate in each, you can limit the geolocation in each area and see only the tweets in one area. Of course, we also show the temporal distribution as a timeline and sentiment distribution. In the end, we show an image wall, which shows the thumbnails of the images in the tweets. TripAdvisor dashboards, most importantly, the sentiment distribution as shown in this little this graph, and of course the rating distribution. So because we also retrieve the ratings of users and visitors, and this can really see, for example, whether the visitors are satisfied with the site or not. And the most important thing is the thematic summarization cloud, which I showed in the previous slides. And here is an example that can be applied to the TripAdvisor data. Improve My City dashboard includes the issues heat map, which shows the geospatial distribution of issues, and city managers can, of course, see, okay, this is the area I'm responsible of, and I can really check this area. And the sentiment map and shows the sentiment in the map. And Tech Cloud is the title and description of the issue, and this is as well a summarization of the things. Of course, you see a sentiment bar on the bottom. Facebook dashboards just shows the temporal distribution, and you can also filter based on time and text. And also it shows a sentiment distribution and reaction distribution. For example, in Facebook, you can like a certain post, or you can say, okay, I don't really like it, but it's really awkward or something. You can show different reactions to the post. And we also show the data as well, so that you can interact with. Survey data for Antalya shows the distribution of the basic statistics of the people who filled in the survey, for example, gender, age, occupation, and of course shows the actual answers to the questions as the bar charts you can see. So these are like, how would you rate something from 1 to 5, for example, and this shows the distribution. Same for Cork. So here for parking, because parking is really important for the use case, we use a double pie chart, which is very special here. And it shows the distribution of satisfaction for both on-site parking and off-site parking at the same time. And the inner ring, there are two rings here. The inner ring explains the inner ring can separate between the statistics of on-site parking and off-site parking, and the outer ring shows the off-site parking. In the end, I would like to mention what we have done so far and how much we have contributed to the state of the art. Of course, retrieving news and comments using machine learning from different websites is something new, and the application of the hierarchical hidden Dirichlet process for opinion clustering is something new as well, and the text summarization for multi-article, not only news comment, but also different documents. And we have developed, our colleagues in CERT have developed methods for detecting the sentiment and associated vocabularies for the Greek language. Regarding publications, we have some papers published in journals, and also some contributed talks in conferences, and we have also one journal paper in preparation about the big data analytics of social impacts. Additionally, if you want to check the details, you could refer to the deliverables. They cover almost everything I explained today. Deliverable 6.1 about the initial thought of our methodologies, deliverable 6.2 about visualization, and deliverable 6.3 about the optimized and updated methodologies and also visualizations. Okay. I would like to thank you for today's talk, and I'm open for questions. Okay. What was the most challenging aspect of estimating the social impact of policymaking? So this is indeed a very good question. So at this point, I'm not actually sure how to answer it because it covers different aspects, and the challenge can be the missing data, for example, and something you could not consider before. For ahead, for example, there are really important data in, for example, TikTok, and that's what we have not thought of. And also, this is one challenge point, missing data, and the data we have not thought of. And also different analytics results can contradict with each other, as we can see in the tourism site. So this really is as a CUTLER platform is a tool to help the decision makers to make decisions, but it does not make decision itself for the decision makers. It provides tools to analyze data, to provide the evidence to the policymakers, so that they can better understand the scenario, they can better understand the data, and most importantly, they can better understand the opinions of citizens, for example. And this is the challenge we met in the implementation. Sometimes some people really think that this will make the decision for you. No, this cannot make any decision itself. The platform only provides you evidences and analytical results. I think this is a gap between our technical partners and the people who are in the city, really, to understand each other. Yes, this is the most challenging part, I think. And also you have to understand the data yourself to see that the importance. It's not like you give us a bunch of data and we do the magic and we return you with the result. It's not like this. It's really like you have to understand the data with us. Of course, there might be some discussions, but this is really important to understand your own data. And the next question, which type of data was the most difficult to handle? There are restrictions in use, for example, personal data, etc. And what did you do to overcome these issues? And there are many difficulties in dealing with the data. For example, initially we used the Facebook crawler using their API to crawl Facebook pages, crawl Facebook events. But in the middle of the project, suddenly, because of some external problems, the Facebook website decided not to provide this access to data anymore. So we have to change. So there's some data that we cannot access. It can be considered as a difficulty. Another difficulty I can recall is the web data, especially any web data, because the web is a really dynamic system. So if they change something, you really have to change. So it's not like you build a crawler, you build an extractor, and it works forever. You have to change it every month to deal with new scenarios. And regarding restrictions, I think, as you mentioned, personal data is one restriction. And for survey data, we have to inform that this will be used in our analysis, and this has to be agreed upon site, like when they fill in the survey. So this is one aspect. Another aspect is any kind of data that has personal data that can be used to identify a certain person, and we have also consulted to our workbench one, which deal with the legal aspect of the project, and we have to really make sure that everything we do is legal. And of course, this will limit our access to the data, our analytics, something we could do in principle, but according to law, we could not do. So this is also one challenge that we have met. Thank you for your question. Okay, if there's no further questions, I would like to thank you all for attending today's webinar. And if you have further questions, you can ask me via email or ask our colleagues. And I wish you a nice day. Thank you again. Bye-bye.
Thank you. Bye.